So this is going to be fairly high level. What I wanted to do was give you guys some examples of things. So basically, this work is going to span starting a couple of years ago at the extremely hyped up Obama 2012 campaign and their fundraising stuff that we were working on. Talk about some of the interesting large-scale experiments that we did there, and then talk about some of the recent work that we tried to replicate that on smaller organizations. How do you go from a 20 million email list for $700 million of fundraising to 50,000, 100,000 that most people have to deal with? So kind of to sort of recap, most of the email fundraising practices today are really relying on the good old A/B testing, right? Somebody has an amazing idea or that they think is amazing. They try that idea out on a sample and see if it works better than the existing idea somebody else had, or try 4 ideas, figure out which one works the best, and then that thing gets applied to everyone. And that's what most of the tools today support. So if you're a standard organization that's using Silverpop, Blue State Digital, or even MailChimp, that you kind of get these, you try something, you can do A/B splits and send the best one. And there are lots of problems with that. And we all kind of know those problems, but we often choose to ignore those problems. The second, so the more sophisticated organizations want to do personalization, right? So you sort of say, well, I'm going to segment my list and look at donors or volunteers or people who've been active or people who have been inactive, and then try something out specifically with them and see what works with them, and then use that to send more of those to that target group. And that's kind of the standard stuff out there, right? One of the things that's the biggest problem with this approach is that it ignores anything you know about these people in the list. It completely is data agnostic. Even though this is hyped up as the data-driven approach, where you do experiments and you're testing and you're doing all these things, you're not really using any data. You have all this data sitting around in the back where these people have been opening emails and clicking on emails and donating and doing other things offline as well as online. But none of these approaches take that into account at all. It's always, you wake up in the morning, you have an idea, you test that idea. If that works better, you implement it. If it doesn't work better, you stick with status quo, right? So if you take that approach, here's an example of a table from the Obama 2012 campaign where the x-axis, the columns are, we took every email we sent, and we didn't send that many emails. It was only a few hundred sent to a few billion times. And I used to apologize for that, but it was really the fault of the recipients. They kept clicking, they kept donating, not our fault. And so this is, we categorize each email as subject line is long, the ask is very clear, the subject is a question, is it urgent, it's quirky, it's a long email, a short email, a complex email, the layout is messy, the layout is clean, there's an image in there, how much is the distance from the top to the nearest thing you click on? Are we attacking somebody? Is it a contest about something? Is it a defensive tone? Is it an offensive tone? Are we selling something? All sorts of attributes about an email. So we semi-hand, some automated, and some hand categorized all these emails. And then we segmented our users. We looked at demographic segments on age, gender, ethnicity, income, location, even sort of email suffixes, right? So old people who use AOL, maybe they're still alive, maybe they're not, who knows, MSN, Yahoo, Hotmail, all those sort of things. And what was the biggest outcome of looking at that data was we realized that, so the colors you're seeing, the bars, the magnitude of that, the color is, if an email goes with this attribute, how much more likely is one of these segments likely to click on this or donate on this, right? So if you see a big green bar, it says, like this one, for example, if the subject has a very clear ask, everybody's likely to do something. Everybody's likely to click on it more. If the text is very complex, everybody is less likely to do something. So the biggest takeaway from this, what we found was, it turns out each attribute is either green or red. What we expected to happen was, old people maybe have more attention span, so they're going to start looking at long emails and actually read them and try to understand them. Or people who are in certain parts of the country maybe care more about policy, so they're going to go deeper. And younger people don't have an attention span. They're going to look at if the email is more than 2 lines, ignore. And it turns out that didn't happen. What happened was that a good email was good for everyone at different levels of magnitude, and a bad email was bad for everyone. And so the lesson from what we learned from this was that we really can't treat, you can't treat the whole email list as a whole, which we knew, but then even when you start segmenting, you really can't treat a segment as a monolithic entity. You really have to go down to an individual level to see what is an individual doing. Is this individual, who is not just a demographic or even a donor or a non-donor, an individual has a sequence of emails that they've basically received. Right? So they've opened emails, they've clicked on certain emails, they've taken actions, donations, signups, they've taken them at different times of day. They've given different amounts of money, they've used different browsers, sometimes from their iPhone, sometimes from their iPad, sometimes from their laptops, from different locations, all sorts of things that we know about individual. All these things are ignoring that data. Even though this is deeper than looking at a high level, we're ignoring all this individual level data. And when you start looking at this level of data, you start seeing this graph, this table starts changing completely, where an individual is going to respond to this email, but not at that email. They're going to click on a particular email which might have a certain length, but the next time the action will be different. It's not as simple as that. So basically what we started looking at was basically modeling individual level behavior, looking at each individual as a separate person, as most of them, most of us claim we are, right? And seeing, can I predict your behavior at different types of things? Can I predict, are you going to open an email? Are you going to click on an email? Are you going to donate? Are you going, if I send you this specific email? So it was all about taking a given email and a given individual and predicting behaviors on that for each person. The reason for doing that was, imagine the A/B testing world, right? Where if you say, you know what, I'm going to try, and people try silly things like, I'm going to try red font today. And you send half the people red font, half the people black font. And let's say red font outperforms by whatever, 3%. Let's assume it's even a valid difference, where it's a long-term difference. Then you send red to everyone. And that's stupid, because it outperformed by 3%. It doesn't mean that every person is likely to click on the red font donate button better. And so what this allows you to do is kind of change your testing process to be more prediction-driven, to be more data-driven, right? So how does that work? If you've hypothesized that, let's assume that the red button and the red font and the black font is what you care about. The prediction-driven testing, the way it would work is you would send an email to half the people, same thing with the red, and half the people with black font. And then you would see who clicks on red and who clicks on black. What you would then do is build a predictive model on top of that data that would predict what kind of people, which individuals are likely to click on red versus black. And once you've done that, that basically becomes the basis of your testing. Because the next test you send, you would basically send it, instead of randomly splitting into A and B, you would split it based on what your model has predicted. So if you predict that these people are more likely to click on the red font and these people are more likely to click on the black one, you send them both. You still keep a third group out as control just to make sure that you're actually validating it correctly. But basically all your testing becomes, take historical data, what people have done, use that historical data to build predictive models about individual behavior, use those models to then predict what an individual is going to do next, and use your A/B testing to then validate whether that's correct or not, and then start implementing that. So what I'm going to do is give you several examples of this type of process, how it actually applies in practice, and what kind of tests we did starting off in the 2012 elections, but then some of the more recent experiments that we've been doing with smaller organizations. So here's an example of something we actually did. We had hypothesis that different people care about different issues, and not true actually, but that was the hypothesis, right? So the hypothesis was, some people care about health, and some people care about education, and some people care about the economy. Turns out everybody cared about the economy in 2012. But if you're strange and you care about something other than that, what we do is we send emails out to a third of our of a sample of our list, and then we got clicks and donations back on that email. based on that, we could then build a model that basically predicted for each individual their probability of propensity of clicking on an email or donating to an email about health, donating to an email about education, or donating an email about the economy. Once we did that, it turns out that now you can take everybody else on your list, as many thousands or millions of people you have, and apply this model and kind of sort them into these groups. And one of the, so we did with actually this example, the health, education, economy, and it turned out that we could improve click rates by about 30 to 40%, which is huge. I mean, all the numbers that we found on any of these optimizations were not the typical 2%, 3%, 4%. They were huge, mostly because nothing had been done before. There was, we would talk about doing personalization, but there was really very little actual personalization going on. The second test we did, one of the tests which was interesting, was we wanted to, this was a very silly thing. We were doing something around NBA games, basketball games, and we wanted to figure out which people would be interested in getting an email about signing up for an NBA game, donating based on that. We were going to run some game, and we were going to sell tickets, and blah, blah, blah. And one of the things that we tried was we didn't really have any data on, well, who cares about NBA tickets? So what we did was for a sample of our people, we had their access to their Facebook profiles. So we could scrape their profiles and basically build a text model that predicted who's interested in basketball and who's not interested in basketball. Now, that we can do based on the text of there. We could build a classifier, and we can talk about later how that works. But now that we have this classifier, we wanted to validate that. So then what we did was we ran an experiment where we sent the people we thought were more likely interested in basketball and sent them an email basically asking them to sign up for or to donate based on that or sign up for that basketball game. And then we had a control group that was just random people getting the same email. And we found in that case, again, a 10 to 15% lift in the click rate based on the models that we had built on the text data. So that was a very simple example, but you can imagine generalizing that. So the generalization of that was basically doing prediction-based testing on a lot of different attributes. Who's going to donate? So for a given individual, can I predict how likely they are to donate to a specific email that I'm going to send next? Because then I can use that to decide who should get that email. Can I predict how much they're going to donate? Because if I can predict they're going to donate about $25, $30, then I can see, should I be upselling them to 30, 35, 40? As opposed to somebody else who's going to be donating $200, I'll be downselling them if I gave them a $30 offer, right? So I want to be able to make sure I can give them the right upsell because I can predict what they're going to do. What should we say to them? Should we say the health message, economic message? Should we say the education message? And then more importantly, how often should we be asking them? When are they likely to unsubscribe? Because unlike direct mail, right, the cost here is really the unsub cost. It's free to send emails, but you're going to lose people. And so if we can predict if they're going to unsubscribe very soon, maybe we should stop sending them emails for a little while. Let them recover from the barrage of emails. And those are sort of some of the experiments that we ended up doing. I'll talk very briefly about a few of them, but then I'm happy to talk afterwards in more detail. So this was the model we built about who's going to donate. So for a given point in time, for a given email, what we would do is build a model that would predict for each individual, are they going to donate on this email or not? What is their probability of donating? And so then you get this very typical propensity curve, right, where you predict that if I only send this email to the top 20% of the people, I get 80-something% of the money that I'm going to get from this email. In this case, if you send 50%, you get 97% of the money. And you can sort of decide where you want to be in this curve. Now, this is pretty standard. A lot of people do propensity curves where you predict in this model. The way we use this model was actually interesting. We would use this model was that we would use this to figure out, and this is not happening for every single email, right? So this was happening for a subset of emails where you would do a test send to a sample. Based on the donation rates and the click rates of that sample, you could predict how much that email was going to make. Was it going to be $100,000, $500,000, $1 million? If it's a large email, it's going to make $1 million, $3 million. Then you want to send it to more people. If it's going to be a small email, it's not going to make enough money because over here, what I actually forgot to put here is the unsubscribe curve, right? So unsubscribe curve is hopefully going this way, where if you send an email to everyone, you get all the unsubscribes that you would get on this email. but all the money. If you send it to 20%, you might only get 10% of the unsubscribes, but make 80% of the money. So that's the trade-off. So what you would do is you could predict how important is this email, and then use the importance of that email to decide how many people it goes to. And once you've decided that, then you can go down and choose which people should get this email. Because you have a ranked list based on propensity of donating and propensity of unsubscribing. And you can kind of make this informed trade-off. The other experiments, some of the, very briefly mentioning them, like, one of them was going from emails to attributes, right? A lot of the work that happens in email treats each email as atomic, monolithic entity. Whereas we all know that emails are a set of these, the big chart that I showed you. Is it complex? Is it easy to read? Is it defensive? Is it offensive? Is it positive tone, negative tone, all sorts of things. Once you start converting emails to attributes, then you can start generalizing things beyond the email. If you want to figure out, the next email you're sending, you're not just saying who's going to reply to that email. You're saying the next email is going to be a positive email, which is long, has a short subject line, has a big button in the middle, and has an image. What's the probability of this person donating to that email? And now you're building your models in terms of attributes as opposed to an atomic email entity. So that's probably the most important lesson from all these. Second was email frequency. We're looking at predicting which people are likely to unsubscribe, which people are likely to donate, using that to decide how many emails should I send that person, when should I stop, when should I keep going. Upselling from an email to a donation page. So if you can predict that this person is going to give $15, when they go to the donate page, the first button on the donate page could be $20, right? If they're going to give $35, the first one could be $40. Because if you give the $40 or $15 button, then you're downselling them. If you give the $15 or $40 button, then they're going away. They're lazy. They're going to go away. And that's what we kind of found is if you can use the model to predict how much they're going to give, using that prediction, then incorporating it into the donate page, upsells by about, again, 15, 16, 17%. The last sort of, again, thing that I want to quickly mention is just like I was talking about the text analysis of the NBA message, you can also start doing text analysis on the unsubscribe messages, right? So when people, right now, when you say, why are you unsubscribing, you give people a space and they type. They just type and type and type because people like to say things. One of the nice things about that typing is you can analyze that and see what are your biggest reasons for unsubscribing. And most of the times it's I'm getting too many emails, right? That was the case with Obama campaign. That's the case for most of the other nonprofits we've worked with is I'm getting too many emails. But there are 2 or 3 or 4 other reasons. It's I'm already signed up from another account. This is a duplicate one. I'm not interested anymore. I don't care about you guys anymore. By looking at the text data, what we can do is, what we actually have done is convert those into radio buttons, right? So you can say, why are you unsubscribing? Here's option 1, 2, 3, 4, and you can have an other box. But the nice thing about 1, 2, and 3, 4 is, let's say I'm getting too many emails. The next thing could be, would you like to sign up for a lower frequency email list? Or if the option they check is, I am not interested in this content anymore, I don't support the environment anymore, the next thing you can tell them would be some message that tries to persuade them back to remain on the list. So one nice thing about converting text to these structured attributes is that you can have a follow-up message that is designed, that is targeted at the people who select that option, which you can't do if you're just doing an empty comment box that they click on and subscribe to. So what we've been doing over the last few months is working with other nonprofits. So one of the organizations we've been working with is Australian Conservation Foundation, and they do advocacy and fundraising in Australia around environmental efforts. And the goal was to take the examples that I gave you and turning them into an actual software, turning them into an experimental toolkit that's available open source to anybody who's doing this type of work. Any nonprofit that is today sending emails and getting hopefully individual level data back, because that's the key underneath it. We can build an experiment toolkit for nonprofits to use. And we kind of replicated some of the same work. Can we take individual level data and build predictive models around clicks and opens and donates? Can we help the nonprofits interpret those models? What do they mean? Does it make sense, what we're finding? And then use those models to suggest what experiments should they be running. What attributes of an email should they be testing? Should it be the long versus short? Should it be the positive tone versus negative tone? And then once they've figured out what experiments to run, getting that data back and analyzing the experiments to then go back again to the predictive models and keep going all the way around. So basically, we're in the middle of doing that now. We've kind of spent the past 3 months working with ACF, and we have an open source toolkit that's starting towards that, but we'll be continuing to work on that. So if people are interested in collaborating and in working with us, we're happy to work with people, and I'm happy to answer more questions later. So thank you. Questions? I know this was a whirlwind tour of a lot of things, so, but yeah. Yep.
For a nonprofit that has less than 1 million, even if it's like
Yeah.
3/4 of a million email addresses, the click and open rate being as such, how do you actually get viable results then? Or what would you recommend prioritizing?
Yeah, so I think the big difference becomes if you've got a 20 million long email list, what you can do is it allows you to be lazy and less data driven, right? So what you can do is say, I'm going to take 1 million, and so what we would do is in the million, take 1 million or even a few 100,000 in the morning and send all our variations to the sample, pick the best one and send it to the rest of the 15 million. If you have a smaller list, you can't afford that luxury. You can't because your sample click rate is going to be 1%. If you send it to 10,000 people, it'll be all statistically insignificant. So the only this becomes more and more useful if you're smaller, because you have to test on your entire list and learn from your list for tomorrow. Whereas the Obama campaign could learn in the morning for the same day, you don't have the luxury to learn for tomorrow. You have to learn for longer term. So longitudinal experiments become a lot more important. Email attribution, so breaking emails into attributes helps you generalize, and it becomes much more important, whereas an Obama campaign can treat each email as an entity because it doesn't really matter. We can write another email tomorrow. So that's another thing is you don't have enough resources to write 10 emails every day, right? You're going to write maybe 2. So it becomes more important that you pick that 2 very carefully. Last week we tested long versus short. We found long worked better. So this week let's keep long fixed and vary something else. So you have to be very deliberate in what you're testing. And so this type of approach is much more critical for smaller mailing lists because you don't have the luxury to fail a lot and still be fine. Yep. So on the sending, yeah, so we didn't, other than experiments that we did on the time of send, we mostly, because emails would go out to 20 million people, it took a couple of hours for those things to go out. So we didn't do any smart scheduling there. We would just send to 20 million people on that one. Now, there were experiments that we did for time of day, all that type of stuff, and nothing, there were some drunk donations Friday nights, but other than that, nothing major on timing of things. It was mostly iterative. So it would basically, the idea would be that you would get a test back. Now the problem is there aren't any tools today that help you analyze that data, right? All the tools will give you an open rate or a click rate. If you're really lucky, you might get segment level things, but that's pretty much it. So we would have to get the individual level data back, build this predictive model that would say, okay, who's going to respond to the next email, generate a ranked list for the next email, and then use that. And we automated most of that. Pretty much everything was automated. The model would build, it would update, it would generate a list, it would give it a list name, and then the people sending the emails would just say, I want to pick that list and send it to. But it had to be all done, which is what we're trying to kind of automate it, because it's a pain if you don't have enough resources to do. So. Okay, thank you.